Good afternoon, everyone. Welcome to track 1 of technology. So here we are going to talk about the key security data science use cases. To take the discussion forward, I would like to invite the panel on the stage, Mr. Manoj Kuru Vantadi, Senior Security and Risk Leader, Infosys. Manoj, can we have you on the stage, please? Mr. Ramakrishna Murthy, Director, APAC, Securonics. Mr. Bikash Barai, co-founder, Digital India. And Mr. Sunil Kumar, AVP, Big Data Analytics and Marketplace Engineering, Paytm. Please. So over to you, Manoj.
Good afternoon, guys. Thanks for coming in for the workshop. I know this is track 1, and my first task is to keep you all awake. So track 1, task 1 is to keep all of ourselves awake. So we are going to discuss on the security data science related use cases. You are aware that the kind of theme that we have had for this particular BPM, so that is primarily focusing on the use case, on the data science overall, primarily focusing on security side. So what we are also trying to bring in now in this particular session is look at the specific use cases where we can see how the application of data sciences can come in our organization environment and so on. So as we see, the security data science as a field is now being, has now started to become a founding block to most of the contemporary solutions now, and we will also see that being, used extensively, as the days come. Because of the advancement in different the algorithms and many intelligent solutions that is coming out in the industry. This is also helping the organizations to it's fueling them with an intelligence-driven security mechanism to be in place to be able to detect activities much in advance so that they can take the required actions in place. Besides the usual SIEM capabilities of correlation detection and response and so on, some of the biggest advantages that we see in the data science based solutions is its ability to perform behavior based analytics and anomaly detection and so on. But that said, the path is still long drawn because organizations are still in the process of, I can say, thinking about how to go about doing this because they are still in the SIEM thought process. Some of the challenges what I see in when we come to this particular topic is the variety and velocity. Those are two keywords which come to my mind. So when you talk about variety, it's about the kind of data which is coming in into the system from across the organization, which is different types of data. It need not be just system generated. It could be from any other solutions coming from across the organization landscape and so on. Secondly is the velocity aspect. So velocity would mean that, for instance, we have the data changing at a very faster pace and the size also increasing proportionally, and the systems in place should be able to adapt to that kind of rapidness in the environment. So that is going to be a big challenge. So which is where large solutions based on the data science based algorithms and so on will come into play. The other aspect of the security data science is going to be that how past occurrences of certain type of events can be studied using statistical modeling and so on, which my panelists will also get into, to look at past occurrences and see how that can be leveraged to make decisions at the present and also to possibly forecast to any possible outcome of a positive or a negative outcome. Generally, people will try to focus on the negative outcome. At least from a security perspective, we all would like to see how negative impact can be prevented and so on. So that will also help us, exactly like what I was saying, is to prevent any negative outcomes coming in by getting in the right intelligence-driven solution based on data science in place. In some of you who must have attended yesterday's session on from Cisco, there was one very interesting statistic which was shown on some market study which said we have an MTTI and MTTC, which is the mean time to identify and mean time to contain. So when you talk about a malware attack, the mean time to identify is around 229 days or something like that. And similarly, upon identification, it takes around 89 days to contain or something like that. That is some industry, whatever study that is. So on that, I will pass the note to the mic to the panelists as well. One more aspect that we would also like to cover is how do you differentiate between big data and data science, security data science. So that as a concept, I don't think it was covered specifically throughout the day, because as we can see, the sessions were programmed in such a fashion that you were actually covering the concepts and building it. Now we are past the fundamentals. Now we are looking at use cases where we can see how such deployments can actually help from a security management perspective and using predictive modeling and so on. So that's something we will also touch base on because there is a general misconception that big data and data science is the same and stuff like that. So we will bring in some clarity onto that as well. And in our pre-lunch session, Mr. Ramri from Deloitte said he brought in a very nice quote which actually struck me well. It says, if you torture the data hard enough, it will confess. So that I would see that as more of a very strong point from the data science perspective. So over to you, Vikash, and then to the rest.
Okay, so thanks. So we are supposed to talk about some use cases, right? Practical use cases. So how many of that's okay. So how many of you are from data science, field of data science? Okay, some of you guys, only two. So when this actually invite came to me, the first reaction I had was, I am not a data science guy, okay? And I have this habit that if I go up to speak on any topic, I try to go and read. I don't feel good if I don't read about it enough before going up on stage, even if I don't talk about that. So I like to kind of go and look into the fundamentals a little bit. So I did the same. I mean, data science, I know it's a hot topic. How many of you think data science is new? Yeah, so once you go back and look into it, it's like 50 years, 100 years old things. So I then started going a little bit deeper into it and stuff like that. And then I fortunately found that I did some data science. But I just did not know that I was doing data science. So it's quite some time back, around 10 years back. That's the first use case where I personally worked on. And that was on anti-spam. So in the early days of anti-spam filters, if you remember, there were these signature-based engines, and there was this Razor and many other signature-based engine, and that became a cat and mouse game. So you come up with a rule, the guys, spammers, finds out the rule, they tweak it, and this game was going on for quite some time. And people tried some statistical algorithms, and the moment you think of classification, it's like classification into two groups, spam and non-spam. You can do more complex classification into multiple groups, but the moment you see I have to do classification, the obvious thing that comes to mind is naive Bayes. How many of you know about naive Bayesian? Okay, so a few. So naive Bayesian, I'll give you a quick kind of a high level. He's the data science guy. He can tell more, but at a high level, like suppose we have in a basket various types of fruits. And the fruits could be banana, apple, whatever. And these fruits have certain traits, like for example, the shape, round, long, color, taste, and things like that. So you collect all these various attributes of this fruit, and then you close your eyes, pick up a fruit, and look into, you get some idea about a few traits. So can you predict which fruit it is? So it's that's the kind of high-level modeling of this problem. So interestingly, at that point of time, people had been kind of trying the statistical model so that the adversary cannot predictively defeat the system. The goal was that if I have a rule-based system, if the adversary knows the rule, then the adversary can predictively defeat it. But in statistical algorithms, even if you know the rule, you will not be able to predictively defeat the system. That's an advantage. So Bayesian, so I did some work on using naive Bayesian, this thing, that was part of my master's at my college. Then I did some more work, a little bit further work on that, which was, like suppose at that point of time, I don't know if you remember, people started playing and writing the same word in multiple different ways. Like for example, you can write V with 2 different slash, and instead of writing it as V. So it's like visually similar words which appear in spam. So instead of I, you just use an exclamation mark. So I did some more work on how to detect visually similar spam. So I did not know that I was doing data science, but fortunately I worked on this. So this is one use case which is used predominantly in data science, which is classification. You can use naive Bayes, you can use SVM, you have multiple various types of tools to do this classification. So that's one use case which I worked on. In fact, interestingly, during those days, I remember in Kharagpur, we had quite a few professors. They were working on things like data mining, information retrieval, and things like that. So it just did not have the name called data science. And data science, though the term was first used, I think in 1960s, it became hot just a few years back. So I look at data science more as a confluence, getting together a good marriage of probably statistics and computer science techniques. The next use case which I personally had been associated with was on automating social engineering. So this is again, so during those days we were at IVIS, those who don't know about me, I co-founded a company called IVIS. So we automated the ethical hacking process. We used AI to automate ethical hacking. We got acquired around 1.5 years back by a company called Cigital. So we were working on this automation of ethical hacking. So we worked on another problem, which was, imagine you invite a hacker to break into your organization. This guy comes and figures out one way to break into, and this is a success. He makes you amazed, you think this is a great guy, but then what happens next? He just found out one path to break into. See, the hacking field is not a level playing field. When you are trying to protect, you have to make sure that all the paths are blocked, but the hacker has to just find one. Right? So we thought, can we find out all possible attack paths? So we started using planning algorithms to simulate all the multi-stage attack paths. And while doing that, we saw that it was actually a p-space complete problem. So the moment the number of nodes increased, the amount of space that you need grows so significantly that if you use a computer, you will run out of memory. Okay, so basically, the space complexity also has the same, effect, or in a way has also effect on time complexity. Either you use memory or you use the disk space, right? So at that point of time, big data wasn't there. Okay, so we could not use big data. So I look at big data as a tool and not necessarily data science. I don't know how you all look into it, since you brought that topic up. So we then figured out some hacks on how to deal with this problem, and that was an interesting way to deal with p-space complete problem. We actually got a lot of awards from Intel, UC Berkeley, et cetera, et cetera. It's just that after a little while, we realized that we were getting more awards than business. And nobody was buying our product, but we were getting awards. But anyway, we were trying to do all this cool stuff. So in that, there was another problem which we faced was, once you draw this attack graph, I mean, I don't have a slide. If I could have shown you, just for 30 nodes, it is so complex that you can't visualize it. So we had to work on how do we do the visualization. And visualization is also part of data science. Again, we did some work without knowing that it is data science. That's another instance. We did another work which was on automating social engineering. So this was a hobby project which we did not take it to market, but the penetration testing, ethical hacking, we did take it to the market. We somehow eventually figured out how to sell. But for the automation of automation of social engineering, what we did was, like imagine you are a user and I break into a network and I sit over there and do some MITM art poisoning, etc. And then I start collecting all the data which is flowing on the network. And now I can have a look into what kind of data is coming out of your machine. And based on that, I have to decide whether I'm going to send you a spam mail on shopping or cricket. Or what should be the exact spam mail which will make you click on that. So again, we did certain predictive analytics or clustering and things like that over there. And I think he has a very interesting story to share over there. There's also another company which I noticed called Darktrace. They use certain predictive analytics, etc. So these are some of the use cases which are in security, which I can think, which are related to data science. Though when we did it, data science term was not there.
Sure. And Rama, you can.
Yeah, absolutely. Thank you, Bikash, for that insight and great use cases. So I'll talk a little bit about the use cases in the security space, right? Especially what we are seeing out in the industry when working with various organizations who have problems similar to some of you have today. And I would like to start from the goal, right? I mean, even before talking about data sciences and some of the use cases, why are we doing this? What is the end goal? So some of you would want to know who is the highest risk user in your organization, right? I mean, obviously a lot of offenders doing malicious activities, they may be violating some of the policies, etc. But who is that, the topmost highest risk user that you want to go after? That is the person causing most of the problems to the organizations, probably exfiltrating data as well, intellectual property. And that's where, that's the goal of the data science, right? I mean, how do you get to that person? We are a room full of people here. Can you tell who is good and who is bad, even just having spent one day here together? Probably not, right? I mean, but if we meet on a regular basis, if you're working in the same organization, same office, meet each other every day, you will you will know the behavior of the other person, right? So that's the unknown, right? I mean, that we are dealing with today, which is what is good and what is bad. If you look at some kind of a solution, it's great, right? I mean, we need all this data that's coming in from all our endpoints, network, security, firewalls, applications, whatnot. But it's only telling me, what I know already. I mean, it's a labeled data. It's telling me, okay, look for X kind of activity. But that's not solving the problem. And I know that already. I'll write some signature. And every person is different. Every person's tolerance level is different. So similarly, every person's activities are different in an organization. So how can you set one single threshold for the entire organization? It's just not going to work. And that's where we use techniques like behavioral analytics. And it's actually looking at large sets of activity data for every single user in the organization. And we are talking about not tons and hundreds. We're talking about organizations who have 1.2 million users and their behavior profiles are being created within the products, right? So behavior baselining. So my behavior baseline, for example, I mean, I go to office Monday to Friday, 8 to 10 every single day. So very normal behavior. My system is looking at my activity logs every single day, my badge access, what systems I'm trying to access, what applications do I go to, how many times do I take printouts. how many file uploads do I do, how many file downloads do I do, what kind of data I'm sending. So my behavior baseline is created, and whenever I'm deviating from that behavior baseline is what becomes interesting. Now this is the user I will go after. Rather than looking at all my data in the SIM, which is like millions and millions of records, putting in like room full of analysts and saying, okay, watch every event, and then someone is trying to figure out, is this actually an authorized event? Was there anything malicious or not? We rather have that analysis done have that analysis done by a product or a technology, right? So that is one behavior analysis is one big use case, and similarly, the data is actually used in other techniques as well, what we call as peer group analysis. For example, you got a group of 10 individuals who are actually all reporting to the same manager from same department, same job title, same job function. We would expect everyone to have similar kind of activity and similar kind of role, similar kind of access. Now what if that one person out of the other 9 is doing something which the other 9 are not doing in that group of 10? That person becomes an interesting actor for me. Person of interest, exactly, right? That is where we want to get to. And add these kind of, for example, I'll take the greatest use case that every single customer of ours has today, which is flight risk users. Their data is going out in and out every single day. But the flight risk users, when someone leaves your organization, you probably do a data review, right? What kind of activities did they do in the last 30, 60 days? But data is gone out already 90 days before the person actually left. The reason is they know the company has a policy. He or she would be reviewed when he resigns from the organization. So why wait till the last day? The data is gone like 90 days back. So these kind of things can be detected very, very quickly in the early stages. Look at the behavior patterns of a user. For example, is he or she going to a job website? So that's an indicator. That's only one of the indicators. So I give that user a risk score of, say, 1. So I'm quantifying the risk now. We always talk about risk, right? I mean, there is risk in the organization, there's threat in the organization. Now I'm quantifying that using real data and statistics. Now, when the user goes to a flight job site, I give a risk score of 1. And at the same time, I'm looking at the user's normal behavior as well. Right? How many times is he or she printing? Now, suddenly I see the print activity going up. So I see an activity outlier or activity anomaly for the user. So now this person has become more interesting for me. Now the system says, okay, there's another kind of activity which is anomalous. Let's give this user an additional risk score of 1. Now the user's risk score becomes 1 plus 1, 2. And in addition to that, if that user is again exfiltrating data, typically they are not uploading data to like a box site or a cloud storage solution. If I see that kind of activity as well, which we call as event rarity, that is, a user is performing some kind of an activity which they have never performed in the past. That is, of topmost importance to me. And I say, okay, give it a score of 2. All these can be set and automatically generated by the technology. So now the overall risk score for the user becomes 5. So now aggregated risk score is what you would look at to identify who is the highest risk user in your organization and why is a collection of threat indicators. Combine, which I mentioned, which is going to job sites, abnormal or high utilization of printing activity, and the high number of uploads. So putting all this together, using data science and the underlying techniques is what is telling you, who is my highest risk user within the organization.
So you just explained some of those scenarios about how an insider threat related use cases can happen within an organization. So from your experience, do you see that some of these data science centric solutions, it needs to ride on top of an existing SIM platform, or are these solutions being able to handle the entire set of logs on their own and do something what SIM does plus do something beyond that, which is data science based modeling and red flags and yellow flags and stuff like that? So what has been your experience in that?
So right now, most of the analytic solutions that you see, I mean, which I call the advanced analytics, right? I mean, it's not just correlating data, it's putting things together, creating behavior profile based on certain statistics and algorithms. These platforms today consume data from existing SIMs. We do still, SIMs will still exist. We need them, for log aggregation and some kind of normalization. We talked about big data, right? I mean, it's just so much amount of data, especially in the security space. We have to make sure that we use it intelligently. So some of that filtering is what you can do at the SIM, saying that, okay, I received millions and millions of events. Now, why don't I, filter out something which I obviously know is noise. Yeah. And then you are sending some useful data back to your analytics solution, which is then used for, your analytics purposes. At the same time, there are products out in the market which act as a SIM plus an analytical full-scale analytics solution as well. And that's one of our products as well from Securonics, which we offer. Yeah.
Okay, thank you. And Sunil, some of the use cases that you have come across in your work with Paytm and your past experience.
So, since Rama has talked about, since Rama has already talked about a lot of use cases, the data science has actually become a behavioral analysis. It's a forecast plus recommendation and the anomaly detection in a nutshell, so to say. So I'll stick to the e-commerce space, whether it's the Paytm marketplace, it's the banking side of it, or it's the travel side of it, whether it's Make My Trip and these guys. So in a whole lot of these things, the problem that happens is, let's talk about marketplace merchants. As soon as, so Paytm or Flipkart or Snapdeal, these guys are trying to get and consume and more customers into the system so that people are accustomed to e-commerce, etc. While we are doing that, a whole lot of marketing campaigns are being done. You have cashbacks, you have recharges, and then again cashbacks, and then you have discounts, etc. So while we are doing this, we are gaining the customers. There are merchants who are actively looking at these stuff and trying to trick the system. For example, you have an iPhone. Paytm is giving you 10,000 rupees cashback. What they'll do is they'll get their friends, themselves, everybody, they will start to purchase iPhone from the system. They'll get the cash back. The iPhone is back to them, right? So essentially, they gained 10,000 rupees per iPhone sold. So this is not restricted to just this. There is a whole lot of product set, campaigns, etc., which merchants are trying to trick the system. In this particular case, what we would do is we will use the behavioral analysis, and we will use the big data and the real-time gaining of that data to identify. So today, we can even identify whether this person, so if he's doing a recharge for 10 people, and if he's doing a recharge for 100 people, we are able to identify. We essentially build a graph saying that this person interacts with most, this person, this person, and this person. It could be via recharge. It could be via a delivery to the home. It could be via sending an email to them about the Paytm offer, etc. It could be via SMS and all of those stuff. So after we read that, we know that graph, okay, this guy has this relationship sphere, and within this, if the complete cluster is making 10 iPhone purchases, this is identified as the anomaly. So now we go back to that merchant, we completely black him out, and we do all the risk assessment with the cyber cell, etc., and that's what happens. Similarly, it's not just restricted to merchants. Consumers, after they saw in news things like, okay, some merchant is sending you an iPhone and they got a brick, and then they got the amount refunded back to them, consumers actually started doing that deliberately. They would get the phone because the courier company does not bear any responsibility of what was there in the product. So as soon as it reaches home, consumer will call back Paytm and say, oh, I got a break, I need a chargeback. So for those particular cases as well, using their behavior, if new people are coming in and they are doing, so even the things like a person doing a recharge of just 50 rupees every month, essentially tells us he cannot actually afford 100,000 or a 2 lakh, 3 lakh product. So, and he's the same person who is actually saying that, okay, I got a brick instead of an iPhone. So then we actually know that this person most likely would actually be creating a problem. So this is the way we detect. So these are some use cases that we did not figure out while somebody was thinking heuristically. So in fact, if you start to think about it, the number of use cases where consumers started raising problems that I started getting break increased significantly when it was aired on the news channels. So even the data outside of your organization or outside of your purview actually can create problems for you, or those are the places where you need to know that your anomaly detection thresholds, while you generate these scores for people that this person looks legitimate or not, this can significantly go up and down based on what is happening outside of your purview as well. So while we were saying big data, I think about 8 years back when we were building these algorithms, we were figuring out servers, multiple servers doing the same thing, collecting back to the same system. While Yahoo came up with Hadoop, after it came up, we started calling it as poor man's Hadoop. So right, so these are the things happening. Now, the next phase that we're moving towards is attaining that data as fast as possible, taking that information and building them into a real-time graphs so that we know, okay, this person belongs to this person does this, his relatives does this, his relatives are not at all. Even these social profiles. So if you're more active on Facebook, if you're more active on LinkedIn and doing a lot of flights, where you work, all of that information is actually used to identify whether you can commit a fraud or not. When we go to the next level of, so I guess if you guys have used Paytm, you might know that Paytm is actually working across everything, whether it's recharge, flights, travels, payments, cafe coffee day, even auto rickshaws, rickshaw pullers, even small buck shops, even they do Paytm. So we have all of this data. This data has to be collected together, get into a single place as fast as possible. That part is big data, and then we move towards the data science. A lot of the use cases which goes out from Excel to the database, and then to the big data, and then finally the data science. So that's the way the model works. Whole lot of models are created offline, and then they're used real time just to create the correlation and say, okay, this guy looks promising or this guy looks suspicious. So that's how mainly it is done. Talking about more use cases for data science, I think even in, look at the flight scenario. So the way e-flight system, ticketing system works is, as soon as you start to check out, as soon as you start to select a flight, you have to book at least for some time, you have to block the seat for the particular customer. So today, if I'm trying to launch a new flight website, I can easily go write a crawler onto the website, let's say whatever, makemytrip.com, and block all the seats via my algorithms, right? I'll simply crawl them. All the seats are blocked. This is again another threat to the system. So now what we'll do is, based on IPs, based on sudden aspects of everybody searching on the same flight, different flights, what is happening, it's just India, it's just from Delhi to Bangalore, right? If I'm trying to do a campaign from Delhi to Bangalore, I'll block all other websites. Even in SEM, digital marketing, this is what we do. We draw campaigns saying that when I want to promote more of the domestic travel from Delhi to Bangalore, let's say. I'll do campaigns, I'll do a lot of SEM bidding, etc. In that particular case, the other companies, what they can do is they can deploy their own bidding algorithm, saying that this company is actually running their campaign for this particular domain, let's just bid higher on them. Their campaign is lost, they won't get the traffic, we will get the traffic, it will be costly for a while, and then we will eventually go down, and we have actually literally destructed their business. So this is what happens. So that's where we start to analyze all of this traffic in real time. We have to identify, it's the IP, it's the email address, it's the phone number, it's the application ID when you install the apps, etc. We have to correlate all of these together, build the graphs that this is the cluster, this is the related group of people that we use. A basic example that I can tell you is on any travel application, if you have moved 4 screens further, the rate of uninstall goes down by 90%. It's a basic understanding from the signals that how they're using the app. If you moved 4 screens, you will not uninstall the app. This is what the data says. So some of these are the basic things. If somebody is trying to go create a fraud, what he'll do is, the first basic thing that he tries to do is uninstall the Paytm app, install the app again, try to do it with a different number, and then try to commit the fraud via doing some, again, more orders on the same organization. While you have the app ID, we can correlate these are the same people, same phone number, trying to do different things. So that's how we correlate and bring things together to avoid the frauds. So
Just like to add one thing, listening to you, there are a few things that came to my mind which we see out in the field as well. These threat actors are very, very intelligent nowadays. Now they know that you are monitoring them, and we've got different techniques and technologies available. One of the use cases with data science and techniques is comparators, which is looking at patterns which look similar. For example, my name is Ramakrishnamurthy, and my corporate domain email ID is rmurthy@securonics.com. So we are obviously watching who is sending emails to their personal email ID. So now our technology would actually look at all combinations of first name, last initial, last initial, first name. It's a combination of numbers. So now I know that I'm being monitored, and this is the way I'm being monitored. So what I will do is I'll send whatever I want to send outside of the organization, I'll send that document to Manoj and say, Manoj, you forward it, because it will not be caught you send it to my email ID, so it will not be caught. So we realized that, that is what is happening. I mean, the threat actors are very, very intelligent. Now, what you do is you expand that threat technology, right? Now I'm saying, is Manoj sending an email to Gmail, which looks like personal email ID of Rama? And that becomes of interest to me. And similar example like that, right? I mean, what we do is we do link analysis as well. That means you're downloading some data from your internal application or files and folders. Now, that the file and folder, I mean, it's very much of interest to me. So if I'm very intelligent, fraud guy, I mean, I would not upload it to any box site. I will again give it to Manoj and say, Manoj, you send it as an email, or you upload it to box site because you will not be caught because I downloaded this data. But that level of linking is what is done by the underlying technology, right? How do you use that data? I mean, look at the hash of those files, or create some kind of a hash based on the file and folder name, that date timestamps, etc., and the size of the files, and see if that file is traversing somewhere in the organization. I bet you will find a lot of those use cases where people are finding other ways and backdoors to take data out of the organization.
But each of these solutions have their own modeling in place, and how it actually learns about the environment. So from your experience, like how many days or weeks does it take for the product to sit in the environment, analyze user behavior, and then start its anomaly detection and so on? So what is that lag time for the system to be really productive? So any inputs on that?
Especially for the behavior anomaly, right? I mean, you need some good amount of data to create a good behavior baseline for for any user or entity. It need not be just the user. I mean, it can be an IP address, application, device. So we are moving more from a user to an entity-based monitoring, because everything is of interest to us, and we want to see what's happening different at entity level. Now, I would say typically about 30 days is good for us to create a behavior baseline. From that point on, right? Whatever you do, it's real time. As soon as you have some data and some kind of activity has happened, and you have breached the threshold, which is specific to an entity. Again, it's not a static threshold. It's real time from that point of time. But to create a good behavior baseline, at least 30 days is what we would look at.
I wanted to add something that is, see, it can actually work from day zero itself. It is possible, and I'm sure your product also works from day zero. It just gets better over a period of time. Yeah. And the way it is handled is, it's not necessary you have to use statistical algorithms only. I mean, you can actually have a baseline rule-based system.
Pattern-based, yeah.
Yeah, so mostly like people spoke about various rules, right? So you can have certain baseline rules to start with, so that initial effectiveness is less, and then with that you gradually train. That's one. The second thing is that there can be a baseline training irrespective of the organization. Like we all human beings have some patterns, but you as an individual, you have some very specific patterns. So when I build a statistical system, I can at least model you as a human being, and the system can work. And then there can be more supervised or unsupervised learning on top of it. So a data science-based system is not necessary. It will take always X number of days to start functioning. It can start functioning. Typically, I think any product company will try to give you some value from day zero. So it will start from day zero and then gradually get better over a period of time.
The way we implemented at Paytm is, so it's like you have a lot of factors that you start putting in for a particular entity, as Rama said, and those factors, they keep on increasing or decreasing. Whether it's decreasing or not, while you have first built your model, within your model, it finds the correct correlation between across all of those factors and parameters. The way we built is, we built a real-time system where you can generate those factors as you come through it. So now, whether it's a product manager, or it's a business manager, or it's some developer sitting in some corner thinking of something, he would come back and say, looks like I can figure out some factor that, for example, Paytm started with just flights, and we would add flight usage as a parameter as well. So the model starts using that as a parameter as well, and since the model is already built, it has to just create the right correlation with that parameter. As you get more and more data, you start using it, and the model becomes more stronger. The other thing that we do is, as he said about the supervised model and somebody giving you a heuristic, okay, this can happen. It's like a rule engine, and then we can keep on improving. What we do is we say that none of the rule or none of the model needs to be perfect. If there are 10 people, if there are 2 people creating 10 models or 10 rules, I can use all of those rules together, and there's a term called ensemble. We will use the ensembling of all of those models to say, okay, if 8 of the 10 models are saying that this guy is a fraud, yes, he's a fraud. If 2 of them are saying, yeah. So this just increases the risk of false positives increasing from a small number to a very high number. So none of the model is useless. None of the model has to be perfect. You can actually use all the rules, heuristics, or the statistical models to say that things are going perfect.
Yeah. We can pick a couple of questions before, I think we are left with hardly 4 minutes. So Mike can reach. So in the meanwhile, another query I had for Sunil is, you talked about how do we pull in social reputation related stuff. So being in the security industry myself, it's easy for me to visualize that how we can pull in IP address based or MAC address based and such statistics. But how do you see social reputation related data being pulled into the, so I'm talking from the technical standpoint on what kind of data and what kind of feeds are expected from, let's say, Facebook and LinkedIn and Twitter and so on. So how does that work?
So some basic things like if we have to detect the purchasing parity of a particular person, it's pretty easy to understand. So on Facebook, if somebody shares a feed saying he's traveling to Singapore, US, and all of these places, versus somebody who is traveling to places within India. So you can actually guess the price parity of a particular person. For example, in fact, this happened to us that at some point of time, we started sending SMSs to people for the newly launched bus vertical, that 50 rupees off on something. And soon, within a day, we realized that if you're sending 50 rupees off offer to a person who is carrying an iPhone 6s, it's of no use. It's the similar scenario. While somebody is using Facebook to share all of their data, obviously we cannot save that data, it's just personal information. But that trend can actually tell you whether the person falls into a certain price parity, whether the person thinks a lot about while he's going to purchase a camera, whether a person, so all of this data is also currently being used in the retargeting of a particular customer. Things like if you are doing a lot of research on Facebook, asking people on Facebook that, okay, if I take this particular DSLR camera, how does it work? Then Facebook will start showing you offers. And you will also see that there are, in every website that you visit, you will start seeing an ad of DSLR cameras. So this is how it happens. So they are doing a recommendation. We can use the same data to say, okay, what is the price parity, whether he really wants to purchase it or not, and collect that information. He has his friends. If he's trying to commit a fraud, you can have his friend list and figure out, okay, this is the same circle, this is the same cluster. Within this cluster, the amount of frauds are increasing, rather than simply saying this individual is doing the fraud.
Yeah.
So IP address, email IDs, in fact, as he said, on the basis of the email names,
Yeah.
Sunil Kumar and somebody else also with the same names, we can actually figure out these are the same people or group of same people.
Yeah. Any questions from the group?
I just want to ask, we will have SIEM as well, right, in future, or you think this data science tools will incorporate SIEM inside it?
Yeah, so SIM will exist. I mean, it's still, required to some extent, especially for log aggregation, right? And some of the normalization of the logs as well. See, analytics platform, we want to use it optimally. We want it for analytics. But each of the product vendors are moving towards, combining these two technologies and giving out one product. Why do we want our customers to maintain two products in our infrastructure? Might as well combine them, have the underlying layer of big data and SIM type of a solution and analytics on top of it.
Okay, thank you, sir.
See, basically, if you go a little bit deeper, see the problem, if you look at what problem is there with SIEM, the problem is you will have to define a lot of rules, right? Without defining a lot of rules, SIEM doesn't deliver. And the problem is that you don't have too many good guys who can define all those rules, and not just that, customize it based on your organization, right? So this is the problem with SIEM. So actually, data science is coming here to solve this problem. And how does it do so? SIEM as a problem solution or whatever you say is going to be there. But data science is going to empower it. And how will it empower? It is going to build these rules on the fly. And it is not going to build or something. There are already products which can do this. So earlier, SIEM used to take like 6 months to get deployed. Now you can actually have products like Splunk, etc. You can get the product up and running in a matter of weeks. So SIEM is there, it's just that the way SIEM is going to work will be different. It's like the evolution. That's what's going to happen. And UBA is going to become a part of the SOC. So UBA is going to take data from SIEM and also feed data to the SIEM or to the SOC. Okay? So I look at SOC as the bigger picture and UBA being part of it. And not like UBA is the bigger picture and SOC as a part of it, okay? So SOC has lots of functionality and UBA is one of them. And UBA is very powerful story to have. So we can look into SIEM to the next level as the SOC and that's here to stay.
So it's like SIM is the platform and the rules that people create can be created by the data science. And it's like every human, even in a shopkeeper knows if some person is coming in, he will purchase this kind of data. He's actually developing data science within himself, behavioral analytics for them. But he can consume only so much. That's the whole idea. That's where data science or big data comes in and says that, okay, I'll tell you more.
Yeah, one question from my side. Analytics is fine when the data source is correct. It is okay. But if the data is from the spoofed sources, like a spoofed IP or spoofed MAC or a spoofed email, which looks like the legitimate, how do you account for the validity of the analytics research side?
So see, one thing is you can actually do some kind of clustering to segregate like bad data and good data. That's one. But in order to do that, you need at least some sample of good data. So you can actually do that. But at the same time, there are also adversarial methods to game the system, game a statistical system by providing it a lot of skewed data. But then there are also ways to catch it. So there's also a cat and mouse game over there. But generally speaking, statistical algorithms are very hard to defeat in a deterministic manner. Okay, that's why it is statistical in nature. Whereas rule-based systems, if you know the rules, you can defeat it a lot easier to do that. But for a statistical, even if you know the algorithm, you can't deterministically defeat it. Okay, that's the difference between the data science model and the other rule-based model.
Yeah, I think we have run out of time, and I've got a lot of signals to, bail out of this place. Okay, thank you all for joining. I hope we were able to give you some understanding of how some of these, security data science-based use cases can be used in our environments. It's very difficult to discuss this in a very short span of 45 minutes. Feel free to reach out to each of the panelists here to discuss more on probably some of those actual, real cases that you might have in your environment, and to see how, SDS can be made used in reality. So that's going to be very helpful for you guys. Thank you, and have a good day.
So thank you so much, panelists, for the wonderful session. The Smart City session is about to commence. Thank you.